All right, so we've already talked a little bit about vectors, but welcome to vector operations. So in this video, we're going to talk about specifically adding and subtracting vectors. In the next video, you'll talk about multiplication of vectors, which is called the dot product. So when adding two or more vectors, the sum of the vectors is called the resultant. So when you see that resultant, we're talking about adding or subtracting two different vectors. So if you're subtracting two vectors, you can say plus and negative. So think about this. So when you see that resultant, they're talking about adding two or more vectors. The sum is called that resultant. Okay. Graphically or visually, we can see the addition or the sum of vectors by using two methods. One's called the triangular method. One's called the parallelogram method. Okay, so these are the two methods we'll use. Primarily, we'll see the triangular method, and that's the one I'll show you today. Okay, so these are just a couple things to think about. So let's define what these triangular method and the parallelogram method are. So the triangular method, it's called tail to head. Okay, so you draw one vector after another. The initial point, which is the tail of the vector 2, starts at the terminal point, the head of vector 1. So here's the idea. Let's say I draw vector A. Okay, so that means I'm going to start vector 2 at the head. So my red vector is the first vector, A. The second vector is green. Okay, so I start the tail at the head of A, and then I draw my vector, whatever that component vector is. The sum is A plus B. It goes from the tail of A out to where B ends. So there's the sum of the two right there. So that's why they call it triangular. You take one vector, you draw it. The second vector starts where the first one ends. You draw that vector, and then from initial point of A to the head of B, the terminal point, there is the triangle piece. There's the sum right there, that length. Okay, that component vector. Okay, so that's how we add them. That's why it's called the triangular method. So I don't want to say just component. Okay, there's other forms that we're going to look at, but the resultant there is A plus B. So from the tail of A to the head of B, there's your triangle. That's where it gets its name. So the parallelogram method uses the triangle method. It's really the same concept. You draw each vector so their initial points meet. So their tails are going to intersect. Okay, you draw the lines to form a parallelogram, and I'll show you how to do that. You can't use this method to determine the sum of a vector and itself. Okay, so here's what we mean. The tails start together, so I just drew A and B. So here's A, here's vector B. So notice they're meeting at the origin here. Okay, so these would be component vectors. Okay, so to draw that, what I did here from B, I drew a black line. Okay, that was parallel to A. Okay. And then I drew a line from A that was parallel to B. So it goes like this, okay? And where those 2 points meet, so where this one and this one meet, I go from 0, 0, and I draw my line up, and there's the resultant A plus B. Vector A plus vector B is from here to here. So it looks like a parallelogram. So that's how we use those two methods, okay? So I'll primarily be using triangular method, but there are two methods we can use. All right, so again, remember, textbooks are going to let your vectors are going to be probably boldface, but mine will draw a little raise on top. So let vector U be the component vector AB, and let vector V be the component vector CD, and let K be a real number scalar. So here's the definition of how we add and subtract vectors. So when you add two vectors, you add the same components. So like A and C are going to be added together, and B and D are going to be added together. Think of like the X coordinates and the Y coordinates being added together. Okay, the horizontal and the vertical. So if you're going to add two vectors together in component form, this is what it's going to look like. A plus C, comma, B plus D, and you get your vector. When you subtract them, you take A minus C, comma, B minus D. Okay? The product of a scalar and a vector, K times vector U, looks like K times, there's the component vector, and then I just really distribute the K to both components, A and B, and you multiply. So a lot of similarities between properties of real numbers, okay? So this is the definition of how to add, how to subtract two vectors in component form, and how to multiply a scalar and a vector in component form. Now there's other ways we can write vectors, and you'll see that in other videos. We're really speaking about component form today. All right, so let's add some vectors, okay? Let's look at an example. So let's let u, vector u, be the component vector -1, 3, and vector v be 4, 7. Find the component form of each vector. So in part A, I ask for u plus v. So vector u plus vector v. So I go ahead and write each vector. There's u, there's v, and I add like pieces together. I think of my x's, my horizontal components, and my vertical components. So here are my horizontal components being added, -1 plus 4, comma, 3 plus 7. Here it is. So it's 3, 10. So how we draw that is, I drew this example here. So I started at -1 to 3. I started at 0, 0, because this is component form. I went to -1, 3. There's the red. And then from here, I drew my second vector. The second vector is 4, 7. So from here, I go 1, 2, 3, 4 over, and then I went 7 up. 1, 2, 3, 4, 5, 6, 7. So I ended at 310, that vector. So the black line is the sum of u and v. So the sum is 310. That's where it ends, okay? So that's triangular method. Draw one vector. From the end of that vector, the head, you draw the second vector. And then here from the origin, I go up and I got my resultant, okay? B is 3u, so that means we're going to take a vector and triple it, okay? So 3 times vector u, so that equals 3 times -1, comma 3. So each one of these components gets multiplied by 3, so I get -3 and 9, okay? So that would take this arrow, and it would go from -1, 3, and it would shoot out to 3, 9, which is right about here. So that's would extend the length of that vector. That's what the scalar does. Just stretches the vector, makes it longer. Last one, they wanted 2 times vector u plus -1 times vector v. So I write 2 times u plus -1 times v. So I distribute the 2, so I get -2 and 6 here for my first vector, plus, and I distribute the -1 here, so I get -4, -7. Then I combine them with addition. -2 plus -4, comma, 6 plus -7. I get -6, comma, -1. That is my vector there. Okay, so that's how we add, and I try to give you an illustration of the triangular method. Now we'll do one more example. Let u equal -1, comma 3, and v equal 2, 4. So I wanted addition of the 2, subtraction of the 2, and a combination of the 2. So u plus v, I write u, I write v, and I add my same components, -1 plus 2, 3 plus 4, so I get 1, comma 7. Part B, vector u minus v, I have u minus v. Okay, so I take -1 minus 2, 3 minus 4, and I get that, and I get -3, comma, -1. Lastly, 2 times vector u minus 4 times vector v. I write the problem. I replace my vectors with what they actually are, 2 times u minus 4 times v. I distribute first before I add, or in this case subtract, so I get -2 times 6, which is 2 times -1, 2 times 3. 4 times 2 is 8, 4 times 4 is 16. I've got the minus sign. So -2 minus 8, comma, 6 minus 16, and I get -10, comma 10. So that is vector operations with addition, subtraction, and combinations of the both with scalar multiplication. If you have any questions or comments, you can type them below, and we'll see you next time.